Good morning, students. I hope that you are all doing well. I hope that you've had time to be outside with our beautiful weather and that you've had time to work on your packets if you're working on those, or you are doing your online assignments with your teachers if that's the course that you took. So we're going to get started with week 2. We are on our same essential concept, which is our concept 1. It says that students will be able to find the distance between 2 points on a coordinate plane using the Pythagorean theorem. Some optional materials that you would need for this lesson would be paper, pencil, calculator, and if you want a device, you can use a device to take pictures of the slides that we are going over. Y'all ready to get started? All right, here we go, week 2. So last week you saw this example if you tuned in, hopefully that you did tune in, and you saw this example that we went over. Find the shortest distance between the start and end point and round to the nearest hundredth. So we had to calculate the blocks from going from our start point up into our end point there, 7 blocks. And we were missing this length here. We wanted to find what the shortest distance was. Well, we actually, when I was doing it, made a mistake. So I want to see, can you find the mistake? And first let me say, making mistakes, we're human, we're all going to do that. And so this is a good learning opportunity for me and for you, that we're not perfect. So we want to go over our mistake anytime that we can catch it. So let's look at it. Have you found it yet? That's right, 16 plus 49, it is not 55. So this would not be the right answer. But we can find the right answer. 16 plus 49 is what, class? 65. Sometimes when we go really fast with math, we may make a quick mistake. So we need to, anytime, like I said, we need to go back and go over it. So it's 65. We know that 65 is just a little bit over 64, and so this is going to be a little more than 8. We're going to go to our calculator to simplify our square root. So we'll put in 65 into our calculator, take the square root of it, and we get this long decimal expansion, 8.06225, and it says to round to the nearest hundredth. So coming over here, the nearest hundredth is the second place after the decimal. So we need to look at the third place, which is our thousandth, to determine if we need to round up or stay the same. In this case, we have a 2 behind our 6. So we will stay at 8.06. So this shortest distance here is 8, let me use black, 8.06 blocks. And this week, just to make sure, I made some references here. So let's make sure we're right. Yes, 8.06 blocks. Good job. Let's move on to our next example. This is the one that we were finishing up. We ran out of time last week, and we were finishing up. So let's look back at this one. Example number 2 says, Hunter kayaks 48 feet due north in Big Creek Lake. We started to draw our right triangle here. Then he kayaks 55 due east before kayaking diagonally across the lake where he started. What is the total distance Hunter kayaks? So there's a couple of things we have to find here. We have to find what he does diagonally before we can find his total. So we're going to be using the Pythagorean theorem. What is this problem about? Kayaking. What is it asking for? It's asking for the total distance. What do we know? We know that he went north 48 feet. He went east 55. And how do we go about solving it? Well, we're going to use the Pythagorean theorem to solve this missing side, which we know is across from the 90-degree angle. So that is our hypotenuse, which we call C. So let's do some calculations here. 48 squared, if you have your calculator on hand, 48 squared means 48 times 48. So 48 times 48, 2,304. So let's write that down right underneath where we were calculating. You know what, I'm going to fix that just a little bit so you can see it well at home or wherever you're watching from. plus, now we have to find what 55 squared is. So we're going to go back to our calculator, clear it out. 55 times 55, 3,025. 3,025. Double check that. Yes, okay. And now our Pythagorean theorem says that we need to add those two numbers. So we're going to add these two numbers. Oop, my bad. I'm going to already have the 3,025 up there, so I'm going to add 2,304. And I get 5,329. Is that what you guys got at home? Good. Now, we're not really used to seeing our equations from 6th grade, maybe even 5th grade. Our equations this way, we're used to having our variable in front. So because it's an equation, it's balanced on both sides, and we can switch them. So I'm going to rewrite this as c squared. It's a little lag in the smartboard there. C squared equals 5,329 blocks. I'm not finished because I need to get the square root of that. Not c squared, but c. So we're going to go back over to our calculator, and we're going to find the square root of this number. So I'm going to hit the square root button, and it happens to be 73. So the square root of 5,329 is 73. And are we working in blocks here? I wrote blocks earlier, but what are we working in? Feet. Feet, okay? So that was the distance that Hunter kayaked diagonally. 73 feet. Our question asks us to find the total. Our problem asks us to find the total. So what is associated with total? That's right, addition. So now we need to add 73 plus 55 plus 48 so that we can get his total amount of distance that he kayaked that day at Big Creek Lake. So let's go to our calculator. We're going to do 73 plus 55 plus 48. 167 feet is what he kayaked in total. Double check it. Yes. And our little cheat down here, our little reference, just to be sure. Yes, 73 feet diagonally and 176 feet in total. Great job. Give yourself a hand on that one. Okay, next example. This is a square pyramid. I've never seen a live pyramid, but I would like to see one day, an actual pyramid. But this is a square pyramid where with A equaling 7 meters and B equals 48 meters is shown below. What is the length of side C? Okay, so we know that A here is actually the apex of our square pyramid. So our apex, this point here, is going down and hitting the center of our square base. So we know that that's 7 meters from here to the center of this square base. And what do we know about squares? That their sides are all 48, good. These would all be 48 meters. And so now I want to see what this length is here from here. If that is 48 and A is going through the center, then that means that this is half of the distance, the midpoint, half of the distance between 48. And half of 48, 48 divided by 2, 24. So this length is 24 meters here. Okay? So now what can we use? I'm going to pull out what we have there. We have 7, and it's not drawn to scale, so let me fix that a little bit. Let me draw it a little bit better for your eye. Okay, 7 meters here. We know that this is 24, and we're looking for this. It's asking for side C. Okay, so here we go. We can use the Pythagorean theorem that we learned last week. a squared plus b squared equals c squared. And our a would equal 7 meters. Our b would equal 24 meters. And our c. And you can put parentheses around here and square this if you want. Okay? And then so we have, you know what, I'm going to take out those meters. I don't want to confuse you there. I'm just going to say 7 squared plus 24 squared. Okay? So 7 squared would be 7 times 7, which is 49. We know that. And then 24 times 24, I don't know that off the top of my head, but I do have a calculator that we can refer to. So 24 times 24, 576. Oop, need my pen. And now we need to add them. That's our next step. So 576 plus 49. What do we get? 625. And we must take the square root of that. And again, you can rewrite it like we did in our last one. You don't have to. C squared and the square root are going to cancel. And so you're left with C by itself. And then the square root of 625. We're going to hit our square root button. Oop, we got to have our clicker on. Hit our square root button. And C would equal 25. So 25, and we always want to reference the right units here. We were working in meters, so 25 meters is what our C would equal. And let's check our answer. That is correct. Good job, guys. Y'all are rocking and rolling. Woo, we need a brain break. All right, let's see. What do you call a pig that does karate? Do y'all know? Anybody? A pork chop. But even my cameraman laughed at that. All right, example 4 says, find the distance between the 2 points and round to the nearest unit. So we have 2 points on a coordinate grid. What is this problem about? These are reference questions. When you're working mathematics, you want to ask yourself what it's about. You want to talk through it, see what you're given, see what it's asking, so that you can problem solve. So what is this problem about? 2 points on a coordinate grid. There they are. What is it asking? For us to find the distance between the 2 points. They have it drawn out for us. Hello. They have it drawn out for us. What do we know? Our 2 points. And how do we go about solving it? We also know a way to solve it by using the what? That's right, Pythagorean theorem. So we're going to draw a right triangle. We're going to create it. You can either go up and left, or you can go down and right. For this, I'm going to go down and right. Okay. How many units did we go? 1, 2, 3, 4, 5, 6 down. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is this length. So 6 units and 10 units. So we're going to be using our, what do we have? Pythagorean theorem. I'm sure you have memorized it by now. A squared plus b squared equals c squared. Where would our right angle be here? That our 2 legs form. Yes. Right here is where our 2 legs form, our 90-degree angle, our corner. So we're going to plug in our units here. What we have 6 squared plus 10 squared equals, we're not sure yet, right? Question mark, unknown. So we're going to square 6. 6 times 6, 36. And 10 times 10, that's right, 100 equals c squared, okay? And 136, if we add those together, very good, 136. And now I want to flip that so it is catching to my eye and that I read it correctly, because we want to read the variable first. So c squared equals 136. The last step is I need to take the square root of both of these. So I'm going to take the square root of c squared. Those are going to cancel out. And I'm going to take the square root of 136. Like I told you, those are inverses, so they're going to cancel. And now the square root of 136, the 136, and then hit the square root button. We're going to get 11.66, huge long decimal expansion. Round to the nearest unit. So that is to the nearest whole number. So the nearest whole number here, we look back at our tens place. Our tens place tells us if it's 5 or more, we raise the score. If it's 4 or less, we let it rest. So this is more than 5 because it's 6. So we're going to round this up to 12. 12 units here. And let's check just to be certain. Made checkpoints this time so we wouldn't have to recover from our mistakes next week. 12 units, good job. Okay, but suppose you don't have a graph. How can you find the distance between 2 points? There's also another method other than the Pythagorean theorem that you can use if you don't have a coordinate plane, and it's called the distance formula. At first it looks long and maybe a little intimidating to you, but it's very similar to the Pythagorean theorem. In fact, we're going to make the connection in just a second. But it says the distance, the little d stands for distance. So the distance is equal to, we're going to read this out, the square root of x sub 2 minus x sub 1 squared. So the difference of the x's squared plus y sub 2 minus y sub 1 squared, the difference of the y values. We add them together and then we take the square root, which is what we were basically doing in the other previous problems. Let's check one out. Whenever we have this, we're going to find the distance between -3, 5, and 7, -1. We don't have a grid. We don't have a coordinate plane or a graph. So we need to put it into our formula. The steps for doing that are, these are just helpful steps. First, label your points. These 4 things, x2, x1, y2, y1. Plug it into the formula, the distance formula. Simplify inside the parentheses here and here. Square the numbers inside the parentheses because we have exponents there. Then we're going to square the numbers, okay, said that. Add under the radical, we're going to add the 2 parentheses, what we have squared already, and simplify the square root, and then round if necessary. Let's give this one a try. Okay, so I want to plug in, the first thing said for me to label my points. All right, let's label our points. We know that ordered pairs, we talked about this last week, ordered pairs are listed X and then Y. You could think about the alphabet. X comes before Y. So it is listed with our horizontal value and then our vertical value. So here we have a -3, 5. That is an actual X point. This is a Y value. This is an X value, and this is a Y value because we just said X is listed before Y. Whenever I'm doing my points, just like as if I'm counting something, the first thing that I get to would be 0.1. The next point would be 0.2. What would you think the next one would be? 0.3. That's right. So I'm going to put sub 1s, and you may have seen some of these little sub numbers on maybe a footnote in language arts or maybe even in social studies when you're reading a book. It'll have a little sub number, and you go down to where, you know, it may tell you about a specific place or a certain person and insert more information on them. So these are just sub numbers. So here we go. Subscript. That's what it is. All right, so we're going to put this into our formula now. We labeled our points. Now let's plug it in. So D is equal to x2, which in this case would be 7, minus x1, which is a -3. I'm going to put parentheses around that one to hold its value. Big parentheses squared plus y sub 2, which is -1, minus y sub 1, which is 5, close parentheses, and squared. I'm going to step back just to make sure I have it correct. We have 7x squared, or not x squared, but x sub, minus x sub 1, yes, squared, plus y squared, which is -1, or no, I said it again, y sub 1, y sub 2, minus y sub 1, which is 5. This is correct, okay? So let's keep going. So 7, we know, now we have to look at some integer rules here. The next step was to simplify inside of our parentheses. We have two negatives side by side, and when we know we have two negatives side by side, then we know that a negative and a negative is a positive there, because it's negating a negative, which is a plus here, positive. And in this case, now we have a positive 7 and a positive 3, which gives us 10. Let me go back to black, just so the people at home, just so you guys can see that. Plus, negative 1 minus 5. Negative 1 minus 5, those are like signs. So now we have negative 1, take away 5. That's going to, we need to add them. Same sign, add and keep, which would be negative 6 here. All still under the radical. Radical, square root, those are the same. Okay? So here we go. This looks similar to what we had a while ago with our Pythagorean theorem. We had our sides, 6 and 10. So we need to square 10. That's 100. Square 6, negative 6, actually. But a negative times a negative is a positive. So no matter what's here, either a negative or a positive, when you square it, it's going to end in a positive. Okay? Now we add 136, and we're going to take our square root of that. Our square root of 130, look, it's still on there, 11.66. And this one, our 66, 1903, a whole bunch of numbers. But it says round to the nearest tenth. So I'm going to look at my hundredth, and to my nearest tenth is going to be 11.7. So the distance is approximately, we do those little squigglies when we have that, 11.7 units. And just to check it, to be sure, yes, 11.7 units. Good job. Okay? We're going to skip that example. We're going to look at it on here. We have 7, 5, and 9, 3. Suppose we want to put those on our graph. Okay? 7, or you know what? Let's do the distance formula one more time. We might not have time for the graph, so let's do this in real time. Let's see if we can knock it out in, what do we got, 3 minutes? Here we go. So our distance formula would give us x sub 2, which is 9, and x sub 1, which is 7, squared, plus y sub 2, which is 3, minus y sub 1, which is 5. Okay? Y'all ready to go quick? We got 2 minutes. Here we go. 9 minus 7 is 2. When we go quick, we might make a mistake. 3 minus 5 is negative 2. And 2 squared is, good job, 4. And negative 2 squared is also 4. So 4 plus 4 is 8. And the square root of 8 is somewhere around 2 something. Let's see. Let's cheat a little bit. Oh, let's cheat a little bit. Let's see. 2.83 units. Okay, good job. We are going to wrap it up because we are almost out of time. I hope that you will look over distance. I hope that you will look over Pythagorean theorem. There's a lot of great resources. You could check in with your teachers. But in this lesson, you learned 2 methods for finding the distance. You learned if you have a coordinate plane, you can create a right triangle and use the Pythagorean theorem. If you do not have the coordinate plane, you can use the distance formula, which you know are connected in the same. Next week, we're going to start our second essential concept, finding the volume of a cylinder, a cone, and a sphere. Your homework, you have homework, other than what your teacher has assigned you, I'm also assigning you some, is to find an example of each of these in your house. A cylinder, find an example of that, find an example of a cone, and find an example of a sphere. I hope that you will tune in next time and enjoy the rest of your day. Bye-bye.